Hey there, this is Rohan Ray. I'll be teaching you the life cycle of a star. Now, in order for a star to be made, there first need to be a nebula. Now, what is a nebula? Nebula is a cloud of dust and gas composed of 97% hydrogen, 3% helium. Now, what happens in a nebula? Well, there's gravity that causes dust particles and gas particles to clump together to form a protostar. Now, this action of dust particles and gas particles forming a protostar is called accretion. Now, so in order for the protostar to be a star, it has to obtain equilibrium. Now, what is equilibrium? Well, that's the battle between gravity and gas pressure. Now, gravity pulls the gas particles and the dust particles inward towards the core. Now, inside the core, the temperature increases as the gas particles they collide with each other. Thus, as the temperature increases, there is more pressure, which as temperature increases, there'll be more pressure, which is, I believe, Boyle's law. So the pressure is trying to compensate for the gravity that's undergoing, and the pressure is also formed by the fusion between hydrogen and hydrogens, or collision of two particles together, forming heat. Now, in this case, I believe it's dust and gas particles that do that. Now, as I said before, the pressure of the gas particles, they try to resist the collapsing of the nebula. Now, the gas pressure and gravity, when they compensate for each other, when they're practically equal, equilibrium is reached, and thus the birth of a star will happen. Now, if the pressure and gravity cannot compensate for each other, this will result in this thing called a brown dwarf, where there's not enough dust or gas particles that were accreted. So that's when a black dwarf is considered, and that's when pressure wins over gravity. And it's not really a real star. It's like, suppose this is analogous to a gynecologist taking a baby out from the mother, and when he did that, he failed because the baby's dead. That's what a brown dwarf is in the life cycle of a star. So let's start with the life cycle. Like the beginning of the birth of a star. Now, let's start with this thing called the stellar nebula. We already covered stellar nebula, which is practically how the stars have been formed. It's kind of blurry, isn't it? Okay, so afterwards, we created this thing called the sorry. We created. Alright. So afterwards, there's this thing called an average star, which, as I said, it's caused from stellar nebula. Now, an average star, there's fusion happening in which hydrogen, they combine to make helium. Now, the hydrogen that's being combined, it's a rare type of hydrogen that's not necessarily found in Earth. It's like one proton, one neutron, and the typical hydrogen that we find is just one proton. And then afterwards, after the hydrogen, they combine to make helium. A red giant has been formed. Now after all the hydrogens convert to helium by fusion, as I said, that's when the red giant is formed, and that's the beginning of collapsing. Now, typically a red giant is around 100 million to 1 billion kilometers in diameter, and it's reaching 2200 to 3200 degrees Celsius. Now, inside the shell, the core shrinks, and because of the shrink, and also it also heats up, which also assists in pressure. Now, because when the core heats up, that assists in making swelling up the star, making a red giant, and whatnot. So as I said, the core shrinks, and practically what's being made is practically the helium particles. All they're doing is fusing each other to make heavier non-metal material, like for example oxygen or carbon. Now afterwards, there's this thing called the planetary nebula, where the material outside of the red giant, like the outer shell of the red giant, those material, they actually form a planetary nebula. Now, it's used into making the births of bigger of other stars. Now, yeah. Now, practically what it is it rejects all the, gives away all the luminescent gases and clouds and whatnot. And what's revealed is a white dwarf. Now, what a white dwarf is was when gravity wins and pressure loses. So all the material in the inner core, it all combines, collapsing with each other. And that's how a white dwarf is being formed. And what's in it is carbon and oxygen, which will eventually cool down by burning and turn into a black dwarf. Now, as I said, a planetary nebula, it's just excess waste of the outer shell of the red giant. So that's practically what a planetary nebula is. Now, this is a summary of a life cycle of a average star. Now, let's look at a huge star, like one that's like 3 times bigger than the mass of the sun. Now, this is a stellar nebula, which again makes fusion by combining hydrogen, which then makes a massive star, which then fuses hydrogen to make helium. Now, that causes red giant. So it's a red supergiant. Practically, the red supergiant is the same thing as a red giant, except it's just larger because it's from a massive star. Now, yeah, and then the hydrogen and helium. Okay, and the star fuses hydrogen, and then the hydrogen fuses to make helium, and the helium particles, they make the star a little bit hotter, and makes it like a red color because the other parts. Inside the core, all the hydrogen is used up to make helium, as I said before, for the red giant, and the outside shell, it actually still fuses hydrogen to make helium, and however, it's cool. That part of the red supergiant is cooler than the inner core because all the helium is trying to fuse up to make other particles like carbon and oxygen and whatnot. Now, for that part is that is the red part of the supergiant because that's the cooler part. Like, for example, if you think of fire, the blue part of the fire is the hottest, then the yellow is second hottest, and then the red one is the coolest, like in a way that it's colder than the other parts of the fire. Now, afterwards, there's this thing called the supernova, which is different from just being a white dwarf, where gravity wins over pressure, and all these materials, they collapse with each other, and under gravity. And because nuclear fusion, it stops happening, and that creates heat, right? Now, heat assists in making pressure. Now, since pressure is not that much, and heat cannot assist that, since there's no nuclear fusion that's happening, that creates a supernova. Now, a supernova is created when all the material, they collapse with each other, and sonic, and what is it called? Yeah, and shock waves. The enormous shock waves are being formed, and now, those enormous shock waves, that's the formation of the supernova. And what's left is either a neutron star or a black hole. Now, for a neutron star, practically it's the remaining parts of the supernova. It's the remaining parts after the supernova. And it typically results in stars that are 8 to 15 times bigger than the sun, and it's very dense. As I said, it's about 10 to the power 15 grams per centimeter cube. Now, why is it called a supernova? Why is it called a neutron star? Well, because the protons and the electrons, the elementary particles, they cannot withstand gravity. The gravity forces them to fuse with each other to make neutrons. Now, a lot of those elementary particles are still in the remnants, so a lot of neutrons are being formed, thus making the neutron star very dense. As I said before, 10 to the power 15 grams per centimeter cube. Now, that's extremely dense. Now, if it's stars that are bigger than the sun by 20 times, they would typically form a black hole. Now, a black hole, it reaches like, I guess, infinite density, because the material, the gravity wins over that. Gravity wins over pressure, since nuclear fusion is not happening, which generates heat, which assists in pressure. Gravity causes the object to collapse itself, which in this case is, star, and it makes an infinite smallest pinpoint called the black hole. Now, black holes, they're invisible, and because light cannot escape from them, so we can't necessarily see a black hole, even if it's next to us. Now, that is a life cycle of a huge star. Now, let's look at some diagrams to see how it looks like. Sorry, it's my computer right there. Life cycle of a star. Life cycle of a star. Next is life cycle of a frog. Now, this is what it looks like. So we have the stellar nebular. So we have the stellar nebular, and if it's an average star, it becomes a red giant. Then after a planetary nebula, and then a white dwarf. The other example is the massive star, super red giant, and then red supergiant, and then supernova. And it either becomes a neutron star if it's a smaller star, or a black hole if it's big enough to make a black hole. Now, this is my summary of the video. I hope you like it. Thanks for watching. Bye.